Okay, I can evaluate functions using function notation. So, and I've already said this before, that like 8th grade is really kind of about building off of things that you learned in advanced 7th grade, but just giving them like a fancier name, right? Okay, so you've kind of already done this lesson today, except I'm giving it a different name. So you remember y equals mx plus b, right? You worked with that last year. It's graphing linear equations. So we're going to talk about graphing linear functions in Unit 3. But if you go back to 7th grade, and you know what? Let's go back even to before that. If I said a plus b, evaluate that. If a equals 5 and b equals -7, all you did was you substituted those values in, right? You said instead of a, I write 5, and instead of b, I would write -7. So a plus b at these values is -2, right? So that's just evaluating. And if you're looking in what our learning target is, that's the same thing we're doing today. We're just evaluating. We're plugging numbers in for x's and y's and evaluating what it is at that value, which you've done before. So and here's the deal with, I know you're looking at that thinking, there's 4 variables there, right? Well, we know that the y and the x always stay, right? Because our equations in linear form look like this, 3x minus 2, right? So you know that like the x and the y remain part of the equation. What gets replaced is the m and the b, right? Okay, usually. So I could give you an equation with 100 unknowns, okay? I know we have 26 letters in the alphabet, but I would use A, A, B, B, C, C. So as long as I give you the value of 99 of them, couldn't you plug them all in, Garrett, and solve for the last unknown, right? If I gave you an expression with 50 variables and then the value of 49 of them, you would plug 49 of them in, do all the math, and then find out the value of the leftover one, right? So as I'm looking at this, I said to you, okay, let's figure out y equals 2x minus 1 when y is 5. I mean, you remember doing that, right? It just means instead of y, wherever you see a y, we're now going to put 5. So 5 is equal to 2x minus 1. And now I only have one variable, which means solve for it. Add 1, and 6 is equal to 2x. Divide both sides by 2, and so your x value is 3. Not so bad, right? Nothing hard about that. Here's what I need you to do once you solve that, though. You're going to kind of put the icing on the cake here, because what this means when we're given an x and a y, an equation like that, we're talking about lines, right? Lines on graphs, and when we're talking about lines, how do those lines get there? By ordered pairs. So what ordered pair do you think I just created? You're kind of looking at it. I just said when y is 5, x turned out to be 3, right? So I'm going to put the 5 here to start, and when I made y 5, the resulting x value was 3. Kind of like that input-output machine, right? Did I draw a picture of that at the airport, right? When you go into security, okay? So the input was x. I inputted, well, in this case, it was y. So this ordered pair resulted from this substitution. Pretty easy, right? Could I give you the very same equation and say y equals 2x minus 1, except this time could I say x is -7? If I give you x, then now you have to solve for y, right? So this means I'm looking for y when x is -7, okay? Which means y is equal to -14 minus 1, -15. So my answer is going to be written as an ordered pair today. And so what should go there? When x was -7, the y value that resulted was -15. Easy. And that's really what we're doing today with a little spin on it, with a little bit of a twist. So that if you followed that concept, you'll be fine today. So we need to start to talk about something called function notation next. So I want you to write function notation. is a little different way of looking at things. Function notation is instead of y equals, and then your mx plus b, we are replacing y with something that looks like this. So nothing happens different over here. It's the fact that instead of writing y, I now write mx or f of x. So I already said it. You may look at this, and I don't know if you've ever seen it. Do you ever see this maybe on some worksheets? I think there was one snuck in there once, and people are like, what does f times x mean? Your first instinct, if you've never learned about function notation, is probably to think that means f times x. No, it does not, okay? This is said, so put some quotes. Whenever I say put quotes, it means these are the words that will come out of your mouth when you see that. You would say f of x. Not times, it just means f of x. So what does this really mean? In 7th grade, we said y. In 8th grade, we're going to say f of x. So f of x just really means y? Yeah. Why? Not sure. It's just a lesson that is in my curriculum that I need to teach. It's function notation, okay? So f of x is equal to this. So this just replaces y. It still means y. So today we're going to practice not saying y for Unit 3. Because in functions, it's not y. It's f of x. Now, sometimes you'll see g of x. You could see I of x. A lot of times you'll see h of x. That letter can change, okay? It's just another way to say y, and that's what I want you to know, okay? So today, what are our ordered pairs going to look like? It's going to look like x, comma, f of x. Yeah. So if you let yourself get inside your head and get confused easily, because you're going to see that x and you're going to think it's x. F of x is really equal to y. So be very careful with that. So talk yourself into keeping this straight. So now let's do these kinds of problems, except instead of y, it's going to be f of x. So if I were to say to you, p of x is equal to negative 3x minus 5. You have to say to yourself, okay, that just means y. That just means y. I'm seeing an x, but this is the real x, right? This is y together, all right? So what if I were to say to you, okay, find p of x when it equals negative 16. All right. I know. It's really a different way of looking at it. So now you have to ask yourself, what does p of x really mean? Y. Oh, so now the only thing I have to ask myself right now is, where do I put negative 16? There's only two places it can go. It can go here or here. Well, what is it? Is it x or y? It's y. Even though there's a big old x there? Yes. P of x is the same as y. So, my advice, right off the bat, because I'm going to have you put your answer as an ordered pair, so you don't get confused, put it where it belongs. This is y. Where should it go? Right here. So now, some people even like to take it and put it, like make that. So they're looking and their eyes are saying, okay, p of x just means y. So y equals negative 16. So now you got to know where to put that. It's going to go right here, right? It's going to replace the whole p of x. It's not going in there. This whole thing is negative 16. And then once you get it in the right spot, it's kind of like, whoo, home free. Because you know how to do that. The tricky part of today is figuring out where to put it. Which one? Okay? So now you just solve for x. So put 5 here, add 5 here. This is going to give you negative 11 equals negative 3x. And in a perfect world, we would have all whole number answers, but this is algebra. Okay? I know that you know how to turn improper fractions into mixed numbers. Just at least simplify that for me. If you want to leave it 11 thirds, I know that you know that that's the same as what? 3 2/3, which however you want to put it. You could put 3.6 repeating. I don't care. They're all the same to me, okay? 7th grade was the year where you needed to learn those things. So now, what does this mean? It means that, you're going to have to get used to hearing me say this, when P of X is negative 16, X is 11/3, right? So the answer key is going to look like this. I'm going to have the 3 2/3 or 11/3 or whatever you choose. And then in the ordered pair, I'm going to have that highlighted for you to look at. I sent it to you in the text with the remind so you can check your answers as you go. The negative 16 was given. The key is just making sure you put it in the right spot, right? Because if you use this and put that here, you're going to get a whole different ordered pair, aren't you? Okay, you see that? Okay, that was kind of the easy part. So let's take a look at this next. Let's use the same thing. P of X equals negative 3X minus 5. The other thing that you may see is find P at 7. Okay. This is where you start to get in your head and confuse yourself. Don't. All right? Well, are they saying that P of X is equal to 7? No, they're saying find P at 7. Find P at 7. Looks like that. Find P at 7. So, it doesn't say P of X equals 7. And here's the easiest way I can kind of... What's usually in the parentheses? What's in the parenthesis now? So X must be 7. Right? So where should I put it? There. Okay? So it's kind of like I look here. I see that that's 7. So that goes there. You going to follow in that flow there? I look in the parentheses. It's usually the X in the parentheses. But now in the parentheses is 7. That must mean X is 7. So that means that this stays P of X. This becomes 7. And I know you're used to the Y. Just P of X is equal to negative 21 minus 5, which means P of X is equal to negative 26. Okay, but look where I'm at. Shoot, I forgot to set my ordered pair up. And this may happen to you. So now you got to figure out, where does the 7 go? Where does the negative 26 go? So do you see why it's kind of beneficial to know as soon as... So which one goes where? Which one was I given? So what goes in this first spot? 7, because that was my X. And my P of X, which is really Y, is negative 26. So in the answer key, you solved to find negative 26, which is the Y. Then this is going to be highlighted in the answers because I want your answer to look as that ordered pair. Got it? Okay, because we need to do a couple more. All right. Let's do this. And you're going to have one that could be a little confusing. So I'm going to do, you have 3 like this on your worksheet. It'll say H of A equals 5A minus 2. So now I know what you're thinking. Where'd the X go? Just like they could change this to become Y, they can put whatever they want in here too. And you're going to see that 3 times on your worksheet. So, but then I need to give you, find H of A at 0. Okay? Actually, I'm going to use a different equation for this. H of A, because I need you to get used to this. A plus 4. Okay. Because you will see one like that as well. So H of A is equal to 1/2 A plus 4. And then the problem will say, okay, find H of A when it's at 10. So, you don't see y, you don't see x. You really have to stop and think about this. You really want to put the one that you know is in the right spot, but get it in the right spot, otherwise everything's out the window. This is really replacing what? Y. So this is my y, right? Because remember back to what we said here? This just replaces the y, so f of x, h of a, anything of anything is the y. So I'm going to put 10 here. I may even want to put, y is 10. But that doesn't really help if you don't know that that's where the y is, right? So watch what I'm going to do. I'm going to say 10 is equal to 1/2 a plus 4. Good? And once you are to this point, you should be good. Subtract 4. So 6 is equal to 1/2 a. So then what do you do when you have a coefficient that is a fraction? Multiply by the reciprocal, which is just 2, or 2 over 1. So a is 12. And now, if you didn't have this already written, would you look at a and go, oh shoot, where does it go? Which spot does it go in? So there's only one spot. And if h of a is my y and 10 is already there, then 12 has to go there, right? So it's a little more confusing when they decide to change that x to an a, or in your worksheet it's a t, and then they make it an n. So just be aware of that, okay? So what if I take this equation, h of a equals 1/2 a plus 4, and this time say h of -8. All you do, let's walk ourselves through this. You look at it, and you say to yourself, well, it's in the parentheses, right? And what is normally in the parentheses? The a. So where does this go? A. So I know it would be so much easier if it was an x, but it's not. So you just have to remember that these two together equal the y. So in the a spot is in this parenthesis, so I'm going to put it there. So now the trick is, which one is it? Is this really my x or my y? Yeah, it's the x, right? Because this thing is the y. If you can remember that, then by default, the other one has to be the x, right? So now, h of a is equal to 1/2 times what you just made a, or what we're given actually, and then plus 4. So what is half of -8? -4 plus 4, and I'm so glad this happened. It always makes me giggle. Like, you guys have something against 0. Like, you think like it's like some voodoo number, because every time somebody has an answer of 0, you know what they put? No solution. There's nothing out there that works. Like, why are you hating on 0? It's a number just like any other number. So h of a just happens to be 0. People freak out. They're like, oh my gosh, I can't have that as an answer ever. Yes, you can. It's 0. It's just on an axis, right? So don't overthink it. All right. So does this make sense? So what does h of a really equal to? Y, which is 0, which is why I put it in the y spot. Understand? Okay. Think you would be best to just kind of work on some of these now and keeping it straight? Oh, what happened to my computer? Okay.